Good afternoon and welcome to the MSU Denver video walkthrough of the Elementary Acuplacer Study Guide. In this video we are going to be going over solving linear equations, and that's on page 15 of the Elementary Acuplacer Study Guide. And what this section is really about is we have an equation, and in all the other videos prior to this one they've been simply expressions. These are equations, and the main difference is that these say there's an equal sign in there. And that's important because this whole section we're going to be trying to isolate our variable, whether it's x or r or g, on one side of the equation and all the numbers on the other side of the equation, so that eventually we get something that looks like x equals, some number. And that's important. And another important fact about these equations that they're giving us is that there's only going to be one variable in these equations. And so that we really can move all the variable, isolate it to one side, and move the other numbers, and we'll talk about how we do that, to the other side. And so we just have x equals some number, and we can solve for a real number. And we're going to talk about how we do that. But really how we do that is predicated on the fact that we can do anything we want to one side of the equation, one side of the equals bar, right? As long as we do the exact same thing to the other side of the equation. And doing this, we do something to one side of the equation, we do the exact same thing to the other side of the equation. We can kind of peel away and eventually get x or r or g, whatever the variable is, to one side of the equation and everything else on the other side. And so how do we do that? Well, in the first video, we went over the order of operations. And so when we're isolating x, when we're solving for x, we're really doing it kind of in steps. And what those steps look like are they're the opposite. Let me write this down. Opposite of the order of operations. And I'll just put order of operations, OOP, I'll initial that. And it'll make a little bit more sense when I put an example down. But that's how we're going to break down our steps. So I'm going to look for any addition or subtraction because that's the end of PEMDAS, and then I'm going to look for any multiplication or division, and then any exponents. I'm going to kind of work my way up through PEMDAS from the bottom up. And what we do in each of these steps, when we go through the opposite of the order of operations, we're going to do the opposite of the operation performed. And again, this will make more sense in a little bit. And we're going to keep doing this until we have x or r, again, in whatever variable it is, alone on one side. But the very first thing we need to do, as we want to simplify it, and in many of the equations maybe it's already simplified, and I know the first couple examples that we're going to do, it's already simplified, so we don't really do anything. But if it's not, it's important to just simplify it if we can. So I'm just going to jot that down. I'm going to say simplify. If you can. And really, honestly, you're going to hear this, but there's multiple ways to solve things in math. And as long as you follow all the rules that we've taught you, you should come up with the same answer. And so you don't really need to simplify, but it doesn't make any sense not to, because it makes things a lot more difficult when you don't. And there are also things that I might be doing throughout this video, this section. And you might say, well, maybe I can do this first, and what if I do this way? And there will be times when you absolutely can do that. And sometimes it doesn't even make it more difficult to do it another way. There's equally simple ways to do things. And so if you find that, by all means, if you get the same answer, use it. Just understand what you're doing, because sometimes things will work out without really being part of a rule, and so it won't always work out. So just make sure you understand what you're doing. And I'll try to make it so that I always do the simplest thing, but we're human. So without further ado, let me just put down on page 15, which is this page 15 of the study guide, on the top there's just an example. Before the practice problems, there's an actual example that they give, and they walk you through. And so I'm just going to write this example down. And their example is 3x plus 7 equals 1. And before we solve this, I just want to note that I said simplify if you can, right? And by if you can, I mean, well, look at this right here. We have 3x plus 7. And it's important to note, and maybe you already know this, but if you have 3x plus 7, that cannot be simplified. You cannot add 3x and 7. If there's a variable within something, you can't add something that doesn't have a variable to it. So I can't add 3x and a 7, because the 7 here is just a number where the 3x has a variable and a coefficient. So I can't add those together. If I had something like 3x plus 2x, well, they have the same variable, so I can add those together. And when I add them or subtract them, whatever the operation right here might tell us to do, I just simply add the coefficients. So 3x plus 2x is simply 5x. I can add those together. If I had something like 5xy plus 2xy, and we won't see that in this section, but if I did, they have the same set of variables right here. So I can add those together, and that would be, ooh, I almost put a 9 there. That would be 7xy. However, if I have something like even 5x plus 2xy, there's an x here, there's an xy here, so they're different. I cannot add them together. So it's important to understand what we can add together and what we can't add together. When I'm multiplying or dividing things, you know, then there's different rules. I can multiply anything. I'm dividing things, well, depending on what it is, I might be able to simplify it, I might not, but we'll go over that if we run into it, which we won't in this section. But adding or subtracting, we want to follow these rules over here. If they have the same variable, we can absolutely add them. If it's a variable and a non-variable, then it's just like two different variables. We can't add them together. Okay, I'm going to erase this now. And we're going to get back to our little example. So I can't simplify this problem. But I am going to I'm going to follow my first little rule up there about doing the opposite of the order of operations, right? I want to go in the opposite order. And so the last step in the order of operations, the last two steps, are addition and subtraction. And so the first thing I want to look for are, well, firstly, can I simplify? And we already said we can't. Well, can I add or subtract anything? And right here we have 3x plus 7, right? We have a 3 times x plus 7. So the first thing I want to get rid of is the plus 7, because that's at the end of my order of operations. So how do I get rid of that plus 7? Well, the second thing that I told you was to do the opposite operation of the operation performed. And the operation, by that I mean, well, we're adding here. And so I want to do the opposite operation. And what that means is that I'm adding, so I'm going to subtract 7. And well, why do we do that? We want to do the opposite. Well, here, when we do the opposite of adding, I'm going to say minus 7. And why I do that is because what is 7 minus 7? What is a positive 7 minus 7? It's simply 0. So these cancel out, and we have a 0 here. And so then I'm going to rewrite our equation. That's 3x, and essentially it's 3x plus 0, or just 3x, equals, well, whatever I do, like I said, whatever I do to one side of the equation, I have to do it to the other side of the equation. So I'm going to say minus 7 over here. And so I have 1 minus 7, and 1 minus 7, you're going to want to get comfortable with negative numbers. 1 minus 7 is negative 6. So now my new equation looks like this. 3 times x equals negative 6. Well, on this side of the equation where the x is, all I have is a 3 times, right? So I don't have to worry about the opposite of the order of operation. I only have one operation left. But I want to do the opposite of that operation, right? And that operation is times. I'm saying 3 times x equals negative 6. So the opposite is going to be divided by. So I'm going to divide by 3. Why? Because now I have 3 divided by 3. What's 3 divided by 3? That's simply 1. And so what I'll have down here now is 1 times x, or simply x. But again, whatever I do to one side, I got to do the other side. So I'm going to divide by 3. And then I have negative 6 divided by 3, and that's negative 2. And if you look at the example on the top of page 15, the answer is negative 2. And so, like I said, you want to kind of, when we're isolating x, when we're solving for x, we're doing the opposite of the order of operations. We're looking for any addition or subtraction. And something that I'll note up here is if I have a fraction, like let's call 7 down here, and maybe x plus 5 up here, and we say equals, I don't know, 10. I'm not actually going to solve for this, but I have I have plus 5 up here. I should get rid of that first because that's at the end of the order of operations. But just like before in our expressions, we really think of, when we have fractions, parentheses on the top and bottom of the fractions. I could put the parentheses on the bottom of the fractions there, but it's just one number, so I'm not going to do that. And so my last tip is that if you have fractions, whether you have your x on the top or the bottom, whatever it is, if you have fractions, you really want to work on getting rid of those fractions first. You want to simplify if you can, but after that, work on getting rid of the fractions. And so just to, we'll see some of these examples in the practice problems, but what I would do first here is what I would say, well, that's in parentheses, so what do I do next? I'm looking for any addition, subtraction. I don't see any. And so I'm going to go in multiplication or division. I have a division, right, divided by 7. And I'm going to do the opposite, so that means I'm going to multiply by 7. And now I have 7 over 7, which is just 1, so that cancels out. I got to do the same thing to the other side, so I'm going to divide by 7. And I would work through and solve for x based on that. So that should really give us an understanding of how to solve for x or g or y or whatever we're looking for. And in this section, we should always get just a number. Since there's only one variable in each problem, in each equation, you definitely shouldn't have any other variables, but you should never have, well, x is equal to 5x plus 2. Well, no, we want to make sure all the x's are on one side, and then we'll just solve for x completely. And so what's left on the other side of the equation should just be a number, whether it's positive or negative, or maybe even a fraction. It should just be a number. All right, and that should pretty much end it for us here, and we should be able to do the example problems now, and I'll go over as we run into if we do run into anything else, as we do the practice problems, I'll go over it as they come up. But since this video is already at 12 minutes, I'm going to go ahead and stop the video here, and we'll start with because again, there's 15 example problems, 15 practice problems. I'm going to do that in the next video. All right, I'll see you there. All right, welcome back to the MSU Denver video walkthrough of the Elementary Accuplacer Study Guide. In this video, we are going to be going over the practice problems of the section on solving linear equations. That's page 15 of the Elementary Accuplacer Study Guide. And in this section, there are 15 practice problems. I am going to be going over all of the odd ones, and I will leave the even ones for you all to go over. If you do have any questions on any of the even ones or any of the problems that I went through in this video walkthrough, please come into the tutoring center, get an explanation, or if that's not possible, try leaving a comment below and we'll see if we can get to you. We will absolutely try to get to all the questions that we have below. All right, so without further ado, let's get started. The first problem in this is 7x plus 8 equals 1. And again, our objective in this section is to solve for x so that it's just x equals some number. And as I stated in the previous video on explaining, we're going to start with any addition or subtraction that we have. So I'm going to go to this plus 8 here. I'm going to do the opposite of what it's doing. So I'm going to minus 8. Whatever I do to one side, I do have to do the other side. So I'm going to subtract 8. And I'm going to be going through these problems not quickly, but I'm not going to explain every step that I do. So if you do need any further explanation, please refer to the previous video or come into the tutoring center. And so when we do that, when we say, well, we have 8 minus 8, that's just 0. So over here I have 7x plus 0, or just 7x, equals 1 minus 8 is negative 7. The next step I'm going to do is I'm going to do the opposite. I have 7 times x here. I'm going to divide by 7. 7 divided by 7 is just 1. So I have 1x, or just x left. I have to do the exact same thing to the other side of the equation, so I'm going to divide by 7. And a negative 7 divided by a positive 7 is a negative 1. And if we look on page 52 for our answer key, problem 1, the answer is negative 1. All right, number 3. Scoot that up a little bit. Number 3 says 5x plus 2 equals 3x minus 6. And again, the first thing I want to do is simplify. I don't have to do that here. I can't simplify really, but I want to gather all the x's on one side before I really do anything else. And you don't have to do that. Again, there's different ways to complete this. You can do different things in different orders, but what I'm going to do is I'm going to move all the x's to one side first. And since I have more x's over here, I'm going to move this. I'm going to subtract, because this is a plus 3x. We're not really doing an operation of plus, but it is a positive 3x. I'm going to minus 3x from this side. I'm going to subtract 3x from this side, so that I have a positive 5x minus 3x is a positive 2x. And the reason I subtracted 3x is because, well, what do I have over here? I have 3x minus 3x. What's 3x minus 3x? Well, that's simply 0. And so I don't have anything, so I moved all my x's to one side. I still have a plus 2 over here, and it's still equal to minus 6 or a negative 6. And so now, again, I'm going to work backwards from the order of operations. I want to get rid of this plus 2, and so to get rid of a plus 2, I'm going to minus 2. Why? Because 2 minus 2 is 0. And then whatever I do to one side, I have to do the other side. So I'm going to subtract 2 over here, and then I have 2x equals negative 6 minus 2. We want to get comfortable with this. Negative 6 minus 2 is negative 8. I'm almost done. I have a 2 times x, right? I want to do the opposite, so I'm going to divide by 2. Why? Because 2 divided by 2 is 1. And so now I just have 1x, or just simply x, and equals, well, I have to do the same exact thing to the other side. I'm going to divide by 2. Now I have negative 8 divided by positive 2 is equal to negative 4. And if we look in the back, our answer is negative 4. So hopefully these first couple aren't too complicated, aren't too unfamiliar, or at least you're getting comfortable with what we're doing. It will get a little bit more complicated as we go along, but again, we'll walk through it and I'll explain my steps on the way. All right, so number 5. I'm going to scoot this up a little bit more. Number 5. Number 5 says negative 4t plus 5t minus 8 plus 4 equals 6t minus 4. And this might look a little complicated right now, but really once we simplify, which is one of the things we want to do, once we simplify, it's really not that complicated. And just a note is, if you guys practiced number 4, the previous problem, which I did not do on here, you want to make sure you distribute, and that's part of simplifying. You want to make sure you distribute anything that you have to. Combining like terms is also, which we'll do here, but also distributing. So if you have to distribute, by all means do that, and you should have done that in problem 4. But here, there's no distributing, but there is combining like terms. And by like terms, I mean this one has negative 4t has a t in it, and plus 5 has a t in it. They have the same variable, so I can combine those together. And when I do that, I just look at really the coefficients, and the coefficients are just the numbers in front here. And so I have a negative 4 plus 5, and we know that's just a positive 1, and it's a positive 1t because the variable is t. I'm not going to put the 1 down, but it's t. And then here I have, well, I just have numbers, minus 8 and plus 4, and so I can just add those together. Minus 8 plus 4 is minus 4. And that equals, and there's nothing to really simplify over on this side, so I have t minus 4 equals 6t minus 4. Okay? All right, and it's not going to end up mattering in this one, but I want to get all my t's to one side, and I'm going to move them over to this side because, you know, there's more t's over there. So I'm going to subtract 1t because that's a positive t. I'm going to subtract 1t. T minus t is simply 0, so I have no t's left on that side. I have simply minus 4. But whatever I do to one side, I have to do the other side, so I'm going to minus t. 6t minus 1t is 5t, and I still have the minus 4. I'm going to move over to the right, but what I want to do here is I want to get t alone. So what do? Well, I'm going to deal with this minus 4. I have to do the opposite of what it's doing, so I'm going to add 4. Why? Because minus 4 plus 4 is 0, and that's what my goal is to get t alone. So I'm going to plus 4 to the other side. Well, this is going to get a little tricky. Now, what's minus 4 plus 4 over here? That's also 0. So what I end up having is 5t equals 0. Or if you want to keep it on the same side, I had 0 over here equals 5t. It's the same exact equation. I just flipped out. I like my variable being on my left, but it doesn't matter. I'm going to erase this down here. I'm just to know, let you guys know it's the same thing. But what do I do now? I have 5. I still have to solve for t. I have 5 times t equals 0. 5 times, so I'm going to divide by 5. Why? Because 5 divided by 5 is 1. So then I have just t on this side. I have to divide by 5 on this side. What is 0 divided by 5? 0 divided by anything is 0 until you get to 0 divided by 0. But, normal numbers, 0 divided by anything is 0. Taking into the account that you can't divide by 0, so that gets a little tricky. You don't get into that anywhere near this class. But 0 divided by 5 is simply 0, and so our answer is t equals 0, and if we look in the back, that's the correct answer. And so, you know, if you're working on a problem and you get something like this, don't look at it and say, well, I must be wrong. Plug it back in to the original equation and see if it makes any sense. You know, if we plug it back into the original equation up here, it would make sense. But you know, just because you get t equals 0 does not mean your answer has to be wrong, that you did something wrong. But just don't get confused, right? Because you can divide 0, 0 divided by, anything. You can do that. A lot of people see, oh, I can't divide by 0. I can't say 10 divided by 0 because that's not a number. But you can take 0 and divide it by something. So don't get confused between the two things. If 0 is in the denominator, that's bad, and you shouldn't see that anywhere in this study guide. But if 0 is on the numerator, that's perfectly okay. All right, let's move on to number 7. Number 7 says 7, and then has a bracket. I'll put a little squiggly line there so I don't mix up my problems. 7 bracket 2 minus parentheses, and brackets and parentheses, they really mean the same thing. They just differentiate. If you have multiple, you can do that. You don't have to. 3 plus 4x, close that one, close this one, minus 2x equals, to make sure I'm staying with the same problem here, equals negative 9 plus 2, and then parentheses 1 minus 10x. All right, so I'm going to work on the left side of the equation first. And with the order of operations, I want to simplify, so I'm going to go into my innermost parentheses. I'm going to go in here, and I know that I can't add 3 plus 4x. There's nothing I could do. Okay, but now I have 2 minus all that. And what's important here is that it's 2 minus, right? And then there's a parentheses. And what this really is negative 1. And why that's important is because we need to distribute that negative 1, right? Just like, in problem, if you did problem 4, we need to distribute. Well, there's a negative 1 here that we need to distribute. We can't just take those parentheses away because we can't do anything here. When there's a minus, we have to distribute the negative. And so what that would look like is I still have the 7 here in a bracket, and I have 2. And then if I distribute the negative, I have minus 3. But then I distribute the negative to the 4x, and I have minus 4x. And then I have minus, and bracket, minus 2x equals. And so if we just took away the parentheses, I would have said 2 minus 3x plus 4x, and that's not correct. We have to distribute that negative. And that's something that maybe you're not comfortable with, maybe you are comfortable with, but whether you are or not, you want to make sure you do get comfortable with that, because it's an important aspect in all of math that you want to get comfortable with, is distributing that negative if it's necessary. And now I'm going to work on my right side, on the right side of my equation. I just have a negative 9 still here, but I'm going to distribute this 2 in there. And that should be maybe, hopefully you're a little bit more comfortable because it's an actual number, well, that's, the negative 1's an actual number too, but you don't really see the negative 1 there. But really, even if it was a plus 1, we could say we're still distributing the plus 1, but if you distribute a plus 1, multiplying anything by a positive 1 doesn't do anything. Multiplying something by a negative 1 changes the sign. All right, so over here we're distributing our 2, and I have 2 times 1, so that's just plus 2, and then 2 times a negative 10x, so that's minus 20x. And the next thing I want to do, well, I still need to simplify, distribute actually, over on the left-hand side. I need to combine like terms over the right-hand side. So if I distribute this 7, well, actually, excuse me, I should actually combine these like terms over here first. And so I have 7 bracket, I have 2 minus 3. 2 minus 3 is negative 1 minus 4x. I can't combine the 4x because it has a variable. And then outside those brackets, I have minus 2x. And then on the other side of this, I have minus 9 plus 2. That becomes minus 7 minus 20x. You could say negative 7. It's the same thing. And now I'm going to distribute my 7 over on the left. So 7 times negative 1 is negative 7. 7 times negative 4x is minus 28. I just said 7 times negative 4 is minus 28. And the x, because I don't have an x, I don't have a variable here with the 7, it just stays as x. And then now my brackets are gone, so I can say minus 2x equals negative 7 minus 20x. And if you're comfortable doing this in, fewer steps, doing a couple things at once, as long as you're completing everything that you need to complete, that's perfectly okay. So now I have minus 7, and I have a minus 28x minus 2x, so that's going to be minus 30x equals negative 7 plus, oh, I'm sorry, not plus, minus 20x. And if you can kind of see where this is going, which is why I stuttered a little bit earlier, I didn't choose the problems based on the answers, but we're going to get another 0. But let's keep going. I want all my x's on one side, and if I can't get a positive x, on one side before I finish, that's okay. We can work with that. But I do want to choose a side. And actually, oh, that's not true. Okay, so I'm going to move all these x's, my negative 30x, over to the other side so that I'll end up with a positive x. Actually, you know what? I'm not going to do that. I'm going to do it the other way because I want to show you something at the end. So I'm going to move these x's over to the other side. And how do I do that? Well, we have minus 20x here. I'm going to add 20x. I'm going to say plus 20x. Why? Because negative 20x plus 20x is 0. So I'm going to plus 20x over here. And again, normally I would make it so my x's are positive, but you don't have to, and that's why I'm showing you this. And so negative 30x plus 20x, I have a negative 7 still, and then negative 30 plus 20, that's negative 10x equals negative 7. I want to get rid of this negative 7x over here, so I'm going to add 7. I'm going to say plus 7. Negative 7 plus 7 is 0. I'm going to plus 7 to this side, and I get negative 10x is equal to 0. And now, it's not going to matter at this point, but if it were a number over here, the next step, I have negative 10 times x. I want to divide by negative 10. If I divided by just by 10, then I would have negative x equals something. And I don't want negative x equals something. I want x equals something. So you want to include the sign in what you're dividing by. It's a negative 10x. I'm going to divide by negative 10. Negative 10 divided by negative 10 is still just a positive 1. I'm going to divide 0 by negative 10. It doesn't matter what I divide 0 by, except it's 0. But 0 by negative 10 is 0. So now x is equal to 0. And if we check the back, that's our final answer. Again, if I didn't look at the answers before I chose these problems, but if you get a 0, don't freak out and say I must have done something wrong. This test is going to be multiple choice. So first thing I would do is see if there's a 0 in my multiple choice answers. If you don't, find your answer in there, well then, try backtracking, because this is a pretty long problem. It's easy to, add it where you sort of subtract, or something minor like that. Especially if you go quick. So take your time. We move on to the next problem. The next problem is number 9. Next problem for us anyway. Number 9. I'm gonna put a little squiggly line here still. All right. Number 9 says negative 5 over 9, negative 5 ninths times k is equal to 2. And at the beginning of the video I said, my tip is to get rid of fractions first. So how do I get rid of this fraction over here? Because if we want to get k by itself, and we do the opposite, the opposite order of the order of operations, well, like we talked about in the very first video that we did, multiplication and division are really like on par with each other. So which one do I have to do first? Well, really you could do either one first, but I like to get rid of my fractions. So I'm gonna say that I'm gonna actually rewrite this first. I can say that this whole thing is the same thing as negative 5k, right? If I put k over 1, then I just have fractions, and I can say, well, that's the same thing as negative 5k over 9 equals 2. And it's going to make a little bit easier to see what we're going to do next. You don't have to do that if you can kind of see what's going on, but I like doing that. And so what do I want to do? I want to get rid of the 9. I want to get rid of my fractions. So I'm dividing by 9, so I'm going to multiply this whole thing up here by 9. Why? Because now I have 9 divided by 9, which is simply 1. And so I have negative, I'm going to move it down here, negative 5k equals, whatever I do to one side, I got to do it to the other side, so I'm going to multiply this side. I multiply by 9 over here. I multiply this side by 9. I get negative 5k equals 9 times 2 is 18. And then the last thing that I do, I have a negative 5 times k. Just like I said in the previous problem, I want to divide by the negative 5, not just 5, negative 5. I'm going to divide this by negative 5, and this becomes negative 5 divided by 5 is negative 5 divided by negative 5 is 1. And so I have k equals 18 over negative 5. And I'm not sure if I said this in previous videos, but that's the exact same. I probably said it in the video on fractions. This is the exact same thing as negative 18 over 5, right? If I move the negative up. Or I can move the negative out in front and just say negative 18 over 5. And I think this one is usually what people want to see, where the negative's out in front. But if you have this first answer here, because that's the way we did it, and then you see maybe on the test or in the back of the booklet, you see this second answer here, it's the exact same thing. All right, and as is the third. So if you see the third one too, just understand it's the exact same thing. All right, let's keep going. Next we have number 11. Number 11 says g, let me put another squiggly up here, g minus 10 divided by 3 plus 2 over 5 equals negative g over 3 divided by 3. All right, so here's the valuable life lesson. We're all human. I just did that whole problem. I didn't distribute correctly at the beginning. I ended up getting the wrong answer, and I didn't notice until the end, so I just deleted all that. So the video is not quite as long, and you guys didn't see my glaring mistakes, but everybody makes mistakes. So let's try this one again. I just did all of 11. We gotta redo it now. So the first thing I want to do is get rid of fractions, right? But before I get rid of my fractions, I really need to make sure I have just one fraction on each side. And we'll go rid of, we'll get rid of the fractions once we combine it. But before I start trying to get rid of my fractions, I need to simplify, I guess. And the way we do that here is we simply combine these two fractions, and we have different denominators, so I got to make sure I get a common denominator first. But to do that, I'm going to multiply this, and if you're having trouble, like I just did, please refer back to our fractions video. I'm going to multiply this 5 by 3 to get a common denominator. I'm going to multiply the top by 3. I'm going to multiply the bottom over here by 5, and then I need to multiply the top by 5. I need to multiply the whole top by 5. Because if I just said, 5 times g, and then I just left it as 5 times g minus 10, that would not be correct. I need to distribute the 5 to the g and to the negative 10. I actually explained this to you guys before I deleted it, and then I didn't actually do it. So even though I'm thinking of it, and it's really easy to make mistakes, especially on longer problems. Make simple mistakes even though we know what we're doing. So here we go. What it should look like is I distribute the 5, so I have 5g, and then I distribute the 5 to the negative 10, so I have minus 50. I left it as negative 10 before. And then I'm going to do this in one step because we should be comfortable with fractions. Plus 6 over our common denominator of 15 equals negative g over 3. And I'm actually going to erase this negative 50 plus 6 and just leave that as minus 44. I'm just going to reduce that right now so we can kind of move along. And then once I have one fraction on each side, if I have just one fraction, then it's fairly simple to get rid of. And if I have two, I can just take it in steps. But what I want to show you right now is what's called cross multiplying. And I'm going to say that I'm just going to write it very simple, a over b, and this can be an expression or just a number or whatever, equals c over d. If I have two fractions, I can simply multiply, cross multiply like that. And my answer would look something like a times d equals c times b. And if you're familiar with this, by all means, you can use this right now or just keep going. But it's just a quick kind of shortcut to use so we can skip a step. And so I'm actually going to do the whole thing out of here. But the reason I'm going to do the whole thing is that so I can prove it to you that it actually works. And so I want to get rid of this 15 right here. So what do? Well, I have to multiply the whole top by 15. I'm going to write it small over here. But 15 over 15 is simply 1, so that goes away. And I'm going to multiply this whole thing by 15. And you might see that, well, I don't even have to do anything with the 3. I can just simplify this 15 right here and say that's just negative 5g. And if you can see that, that's great. You can do that. But I want to prove that the cross multiplication works. So I'm going to say, well, I want to get rid of this 3 down here, so I'm going to multiply by 3. And those 3 cancel out. 3 over 3 is just 1. They cancel out. And I got to multiply this by 3. And so now I'm going to rewrite it without distributing. And if we do that, we get 3 times 5g minus 44 is equal to negative g times 15. And if we look back at my example with the cross multiplication over here, a times d, we would have, our numerator over here times 3, which is what we have right here, and then our numerator over here, negative g, times our denominator right here, 15, so negative, and that's what we have right here. And so it should look like what we just did over here. Again, if you chose to reduce this 15 over here before, that's perfectly okay, and it'd actually make it a little bit easier later. But I wanted to prove to you that you can cross multiply, especially when it doesn't reduce. And it's it takes out a few steps. In that step, we just kind of made it longer, but let's keep going with the problem. So now I'm going to distribute. I have 3 times 5g is 15g, and then 3 times 44 times negative 44, and we wouldn't really have to do this if we reduce, but that's okay. 3 times negative 44 is negative 132. And if it takes you a second to get that, it's just 3 times 44, so you just have to add them, negative 44 and minus 44 minus 44, but it's negative 132. And then we simply do negative g times the 15, so we have negative 15g. And from here we want to, just like we did before, I want to move all my g's to one side, so I'm actually going to add 15g right here. And then I'm going to add 15g over here. And then so I have negative 15g plus 15g, that's 0. And so my new equation now looks like 30g. I have a 30g minus 132 equals, and then we still have 0. And that's okay to have 0 on one side of the equation. Now we're not done yet, so we're going to keep going. But it's okay. I mean, if you get rid of everything on one side, then you just simply have 0 over there, and that's okay. Well, I need to get rid of this negative 132, so I'm going to add 132. And so then we have 30 times g, 30g equals 132. To get rid of the 30 in front of the 30g, I have to divide by 30, because 30 divided by 30 is simply 1. And I have g equals, well, I got to divide by 30 on this side, 132 over 30. Now simplifying at this point might not be the simplest thing in the world, and if we simplified earlier, that would have been helpful, and I encourage us to do that in earlier videos. It's always good, but we can still do it here. We can still do it at this point. I'm going to pull out, and this isn't, if you can see that we can pull out a 6 out of each one, that's great for you, and just pull out a 6. But I'm going to do it piece by piece here, and I'm going to pull out a 2. And so if I pull out a 2 from each one, and then 2 divided by 2 is simply 1, then I have 132 divided by 2 is 66. And then 15 divided by 2 is, 30 divided by 2 is 15. And then from here, hopefully we can see that, well, I can't divide it by 2 because one's even, one's odd, but I can divide it by 3. And if I pull out a 3 out of each one, then I have 22 over 5. And hopefully this is the correct answer. And it is. It's 22 over 5. I finally got it right. I normally get it right. I don't know. Everybody makes mistakes, right? All right. So 22 over 5, if there were any other confusing points in this problem, it is a long problem, but it really goes over a lot of stuff. And in each section, as you get towards the end of the practice problems, they should be getting really tough. And that's really the sign that you're getting it, is if you can do the last like 3 or 4, and this was like the 5th one, but if you can get those last couple, especially by yourself, then you know you're getting it. All right, so I'm going to move on to number 13. Hopefully I can do this one without too much trouble. All right, I'm going to put a little squiggly there. All right, number 13. 13 says y over, what do we have here? 3 times y plus 4. I want to make sure I write it down correctly. And that's all equal to 1 over, and then 2 plus 4 times 3. And so you might say, hey, we just got excuse me, one fraction on each side. Yeah, this is not so bad, right? But we want to make sure that we simplify. And when we simplify, we talk about going in the order of operations the correct way, right? Just the normal order of operations. And that includes distributing, which isn't really part of the order of operations because, excuse me, in the order of operations where we saw in the first video, we didn't have variables like y or x, and so there was no real distribution. We just did inside the parentheses, like over on the right over here. We just did 2 plus 4, and that's 6, and then we multiplied it. You know, and you could do that, and that's what we should do, and that's what I will do. 2 plus 4 is 6, and then multiply that by 3. But really, if you distributed this 3 and said 3 times 2 is 6, and then 3 times 4 is 12, and you said 6 plus 12 is 18, you'll get the same answer. It's just a little bit longer to do it that way. But since we can't combine over here, let's say y plus 4, then we really do need to distribute that. And so that's a part of our simplification. And so if I rewrite my problem, I have still y on the top. I can't really do anything with just y. And then on the bottom, I'm going to distribute that 3 to the y. So I have 3y plus, and then I distribute the 3 to the 4, and I have plus 12. And then my other side of the equation looks like, well, there's just a 1 on top. And then I'm going to do inside the parentheses, 2 plus 4 is 6, and then I multiply the 6 by the 3, and I get 18. And you might see a y on the top and a y somewhere in the denominator. You might be worried a little bit, but really, just get rid of your fractions first. Let's not worry about that. Let's not worry about trying to solve for y until we get rid of our fractions. And so how do I get rid of these fractions? Well, like in the previous problem, I'm just going to erase this and move back a little bit. In the previous problem, I cross-multiplied, right? And then I proved that it worked. So I'm just going to cross-multiply here. I'm going to say this times, and I got to multiply the whole top by 3y plus 12. Scooch a 1 in there. And then I got to multiply this whole top, which is just y, but I got to multiply that by 18. And then our denominators will go away. And so when I rewrite my problem, it should look something like this. 18y on the left equals, and I have, well, essentially a 1 times this, but 1 times anything is just itself, so I'm just going to put 3y plus 12. And that's what it looks like. That's what our equation looks like after we get rid of the fractions. And so now, again, I want to bring all my y's over to one side, and I have 18 over here, so I'm going to scooch this one over. I'm going to say minus 3, because 3y minus 3y is 0. I have to minus 3 on this side, minus 3y. And I get 15y equals 12. And I have a 15 times y, right? So to get rid of the 15, I got to divide by 15. 15 over 15 is 1. And so I get y equals, well, I got to divide by 15 over there. Y equals 12 over 15, and we can reduce that to 4 over 5. Put a 3 out of each one, and it goes into 4 over 5. So y equals 4 over 5, or 4/5, and that should be the answer, and it is the answer in the back. And hopefully that didn't confuse anybody too much. That was actually a pretty easy one with fractions. All right, let's keep moving. So we're going to do the last problem now, and again, I'm leaving the even problems for you all to do. And if you have any questions on those, please come into the tutoring center. And number 15 says 2x plus 5 over 7 minus x plus 4 over 5 equals 2. And again, my tip is get rid of the fractions, but we have two fractions on the same side, And moving the fraction, one of the fractions over to the other side is going to help us, because then we'd have a whole number plus a fraction. So instead, we're going to get rid of, we're going to not get rid of, but we're going to combine these two into one fraction, right? So I'm going to add or subtract, I guess in this case, fractions. How do I do that? Well, I'm going to multiply this side by 7. I multiply the denominators by each other. And then I'm going to multiply the top by 7, but I have to multiply the whole top, right? So I put parentheses around it. And then I'm going to multiply this side by 5. I'm going to multiply this whole top by 5, and we got to remember to distribute. And so what this should look like now is, well, we distribute and we get 5 times 2x is 10x, plus 5 times 5 is 25, minus, and then I'm going to put in parentheses, because again, here's one of the cases where if we're minusing fractions and it's not just a number, it's an expression up here, it's x plus 4, or it's going to be more than that in this case because we're distributing a 7. But if it's more than just a number, we have to put parentheses so that we distribute this negative. And so now when I distribute the 7, I have 7 times x is 7x, plus 7 times 4 is 28. And that's what it looks like inside the parentheses, right? You just multiply the 7 across. But now we have to distribute that negative, and we'll do that in the next step. That shouldn't really be a squiggly line. This is a division bar. Our common denominator is 35. 7 times 5 is 35, equals 2. And so now I'm going to simplify the top, right? And in order to simplify the top, I first need to distribute this negative to each one of these. And so I'm going to rewrite this. I have 10x plus 25 minus 7x minus 28 all over 35 equals 2. And so you want to make sure that you are you are simplifying and distributing as part of that. Simplifying along the way. We might not have been able to simplify, at first until we combine the fractions, but now we can, and it makes life a lot easier if we simplify before we try to move on. And so now I have the numerator, and so my new numerator, once I combine like terms here, is, well, I have 10x minus 7x, so I have 3x. And then I have 25 minus 28, so that's a minus 3, over 35 is equal to 2. And now we can move on with our solving for x. I want to get rid of the 35 in the denominator, so I'm going to multiply by 35. 35 divided by 35 is simply 1, so I have 3x minus 3. I got to multiply the other side by 35. Got to do the exact same thing to the other side. And I get 2 times 35 is 70. So we'll get 3x minus 3 is equal to 70. Excuse me, I don't know what's going on here. All right. Okay, I was getting a little hesitant that our answer is going to be a little off, but I just checked it and we're on the right track. So now I have 3x minus 3, right? Order of operations, I'm going backwards. I want to get rid of this minus 3, so I'm going to say plus 3. Negative 3 plus 3 is still 0. Plus 3 to this side, I have to do the same thing. So now I have 3x plus 0, or just 3x on one side. And I have equals 73 plus 3 is simply 73. Now I have 3 times x, and again, we've gone through this enough that we can just say, okay, divided by 3, that's just a 1. And so I have x is equal to, well, I got to divide by 3 on this side, and that's 73 over 3. And as non-appealing as that answer might look, it is the correct answer. And so, just keep going if you think you're doing something right. And hopefully, there was nothing too troubling about this one. We added a fraction in the beginning. It wasn't the nicest looking fraction, but as long as, we just multiply the denominators together and we multiply the top and bottom by the same thing, and we make sure we distribute, the 7 and the 5, and then especially that we make sure we distribute this negative here. After that point, it's really just combining like terms. That wasn't too hard, and then solving for x after that. And that's the last problem in this section. And that's really, if you guys can get comfortable with this solving linear equations, that's really, I think, the toughest part of this whole study guide. The next couple of sections kind of build on this, but if you guys have a firm grasp on this section, the next couple sections should go very easy for you. So I will see you in the next video.